Okay, hi. So we're here doing a demo for Chapter 10 of ENSA, and so it's network management. And so it talks, Chapter 10 talks about CDP, LLDP, also setting time and using NTP, and then it talks about SNMP, which I can't really demo here today. But then there's also Syslog, and then there's actually managing iOS files. So we have, as you can see on the screen here, we've got a bit of a topology, just 2 routers, 2 switches, and 2 hosts. And so basically, of course, one of the hosts is a server, and the server actually has some of the services we need for this built in, and I think they're even turned on by default. So if you look at services, I've already mentioned what NTP, that's on by default. Now, I might actually set it to what dates it got. It's October the 13th, and then we'll set it to, well, 4:30 is what my my time is saying. Okay, so that's close enough. And so as you can see, it's on by default. I haven't got authentication set up on it. And so that's all very nice. And also we didn't mention Syslog, and so it actually does do the logging as well. So let's have a bit of a look at this. And so, as I said, the first topic is CDP. Now, to get it running globally, you can just put in a command CDP run. If you want to do it on a per interface basis, it's actually CDP enable on that particular interface. Now, I think this actually has it on by default if I just have a look. So we do show CDP neighbors, and it is working. And so this is R2, and if we look at the topology, R1 is directly connected to it, and also S2, and so that's actually reflected in the information we've got here. And so we can see that S2 is connected via G000, that's your local interface on R2, which of course is what we plugged into. Another 160 seconds until it throws it away as being information being out of date. It's a switch, which S2 does imply. And it's a 2960 switch. And on the switch itself, it's actually the cable is that's plugged into R2 is actually G0/1 for the port. And so, of course, there's R1, and so it's connected to R2 via R2's G001. Again, it's got the same hold time. It's a router. It's an integrated services router, 4300. And it's also on gig 001 on the other router. And so now that's all very nice. If you want more information, you can actually just go detail, and you actually get nearly a screen full of information per device. And so starts out with the switch. So it gives you information, versions. If I had an IP address, it would have been there. I haven't actually set one on the switch, and so it just gives you all that kinds of information. Then if I carry on, here's all the information for router 1. So of course it does have an address, and it tells you a little more depth about that particular device. So that's all very nice. Now, of course, CDP is very nice if you've been dumped in to try and troubleshoot a network that you're not familiar with. CDP can be the tool to use. CDP is often turned off by many administrators, though, because while it's a handy source of information, it can also be a handy source of information for people trying to do reconnaissance on your network before they attack it. So yeah, there's always a downside. Now, CDP, Cisco Discovery Protocol, of course, implies that it is a Cisco proprietary protocol. And so there is an open source version of it called LLDP, which is local link discovery protocol. And so this is standards based, so other vendors do support it. It's an open standard. Now, CDP is running on these devices by default. LLDP is not. So I can actually do an up arrow and just edit it to LLDP, and it will actually say, sorry, it's not enabled. So I've actually got the commands here. So as opposed to CDP run, it's actually LLDP run to turn it on globally. If you want to do it on a per interface basis, you actually have to enable it to both transmit and receive. But we'll just do it globally at the moment, just to have a bit of a quick demo. And so we'll paste that in. Now, R2's running it, but of course, if the neighbours aren't running it, they're not going to exchange any information. So I've got to go into the neighbours as well. And I'll go into the switch. So now if I go back to R2 and do an up arrow or two, I've done detail there. And so this is the command I type in, show LLDP neighbours detail. And so here's all the information about, I'm assuming it is the router. Yes, R1. And so you get a full description of the operating system, of what ports are where. You can get a chassis ID and so on. So then, of course, after the dashes, we get the switches details as well. And so slightly different, but only slightly, really. So yeah, that's LLDP, which is, as I said, an open standard version of CDP. All right, now what we're going to carry on with for the rest of today is, well, for the next session is actually time. And so when we go into Syslog, of course, basically that's a way that you can log messages to a centralized server. And so if I look at this router and do show clock, why didn't I type in show clock? It's Monday, the 1st of March, 1993, according to this router. Now, Cisco devices don't have the CMOS clock running all the time, 24/7, to keep track of time. And so when they boot up, they go back to basically, yeah, the beginning of time, or when Cisco started. And so basically from there, even if you turned on timestamps, it would not be very illuminating. And so you can, of course, manually set the time. Where have I got that? So you can actually do clock set. And I'll do it for 10:15 this morning, just because I can. And so clock set, if I do show clock now, it will actually have a sensible time as opposed to a non-sensible time. But of course, if this router reboots, it will lose track of that time and it will go back to 1993 again. So every time you get a power outage or update your devices, do you really want to be setting the time, or an automated process? And so that's where NTP comes in. And so here is the config that I've got here for NTP. And so basically you can tell it who its server is. And so that is, of course, I already showed you the NTP on the server there. So that's the server's IP address. Now the NTP update calendar basically just speeds up the process of synchronizing the time between the router and the server, because NTP is normally pretty gentle with these things. And so I'll just go copy and paste, and that's got the config in. Now it might take a little time before it actually shows up. Let's do that, show NTP associations. Copy. Now, previous times when I've done this, it's actually sort of put it in an init mode. Okay, it's running a little better. And so you can see that now, of course, basically this server is running from its own clock. It's deemed to be stratum 1 just because it's come directly from a clock and not from other servers. Now, of course, the reliability of the clock is the question mark there. But anyway, and so basically that means that this router would then may be stratum 2 because it's learnt from a stratum 1 device. And so if we do show clock again, let's see what happens. It will synchronize, but of course it's basically stuck with the old time at the moment. And so basically if you put that config into the device, when it boots up, it will actually synchronize the time and then of course give us some meaningful messages. All right, now, so that's the time. Now Syslog, of course, whenever you log into a device, if something's happened to it while you've been away, you will actually get a summary of those messages on the console. Now that's all very fine, but it's not sort of, you know, as it happens. It's only when the only thing that happens as it happens is when you log into the device, and so that's not a particularly good solution. And so Syslog allows your devices to actually send their logs to a centralized server. And so there are open source programs that you can use that will actually run a Syslog server on, you know, maybe it's your station that you manage the network from. You could actually run it on your machine and allow all your devices to log it to your machine. So from there, basically you just tell it what host is going to be logging. Now, when we finish configuring something, so I did that there, you get this message here, a console message here saying configured from console by console. And so that's the message we got. Now there's no timestamp on that. And so of course, as I said, having a timestamp is a useful tool for doing that. And so basically with this command here, it will actually insert a timestamp in front of the message. And so, of course, with that basically, yeah, lets you know exactly when these things happened. And so if someone configured your router, it will tell you what time they configured your router. And so that may be valid or may not be valid. And so you can actually then track it. Now, the reason I've commented this logging on is because I've also got it down here. That's the only reason. Now, if you've looked at the chapter, you'll know this, but basically there's 8 levels of logging that you can turn on. And so basically there's level 0, which is the most critical messages, or you can go down to level 7, which is debugging, which is basically nearly everything that happens on the device. And so on true Cisco devices, you can do logging, trap, and then a level. And so I think from memory 4 is warning. That's what I tried to do a while ago, but Packet Tracer doesn't support it. So and so that's the level I would normally have logging going at, but Packet Tracer only supports one kind of logging, and it's debugging, so level 7. So anyway, and so that's just the reality of Packet Tracer. Now, logging source interface G00. Now, Packet Tracer also does not support this, but the whole point of this command is actually so that the source address will always be the same from this device. So the warning might actually be about interface G00 going down, and so that's never going to be the source address. But if you always put the same source, it will always be in the same list, basically, and that's why people bother doing that, because it normally sorts it just by source address. And so that will always put the same source address on messages from this particular router. And then, of course, you need to actually turn logging on for any of that to happen. And so, again, we'll paste this config into the router. Copy and paste. Don't see any errors. And so now you'll notice that configured from console by console has now got a timestamp on it. And the time has caught up to reality now. And so so that's all very nice. And it also has got logging start stop. And so we've started logging. And so now what we can do is we can go back to the server. Do I still have the window open? No, I don't. Let's have a look. And so you can see now that there's a syslog message on the server. And so there's the logging start stop there, and there's the configured from console by console. And it tells you what host name it is. And so that's the source address that came across. And this is the timestamp. And so 4:37 p.m., which is, of course, when I'm recording this. So that syslog working nicely. So if you want, I could go back to the device. Conf t int g000, do shut. As you can see, we get the status message going down, and of course we've got the timestamp in the front of it. And then I'll do no shut. And of course we get another message saying that it's changed status to up. And so now if we go back to the server, we've got some more messages. And so as you can see, we've got these messages. And so I don't think, I'm not sure if there's actually a way for me to adjust the width of these columns, but anyway. And so there is the messages that came through. So of course, packet tracer it happening is a little on the trivial side, but of course in real life, at least that's a good timely message that you'll get for it. And so yeah, so the syslog is certainly a handy thing, not a big job to set it up. But as I said, there are more options on the real devices, like that doesn't work on packet tracer and that doesn't work on it. And so you can certainly set it up a little bit better in real life as opposed to on packet tracer. All right, now another feature that the server has, which I haven't mentioned yet, is it's a Tftp server by default, so trivial file transfer protocol. Now, basically, the first thing you should do when you buy a new router is actually back up its operating system so that you can then recover later. So I'll just hit end here. And so I can do copy, well, actually, before I do anything, I should do a show flash. This will actually show me what files are in the flash file system. And so this file here is the one I'm interested in. That is the operating system for iOS. So copy. Now I don't have to type that file name in, which, you know, if anyone who's seen me typing, that's probably a good thing. And so now I can do copy flash to TFTP. And so basically I'm going to copy a file from flash to a TFTP server. And so the first thing I want to know is the source file name. So of course I've got that in my, I can paste it in. Now it's going to be the same server, so 192.168.1.10. And the destination file, when I put it there, will be this. And so I've already checked it previously. This file does not exist on the TFTP server, and so now it's going to do the transfer. We'll have a look at the TFTP server because this is going to take some time, sadly. Server, and so it's, the file is ISR 4300, so it's all in alphabetical order. There's no ISR. There's IR, but there's no ISR. And so this is copying away. And as I said, it will take some time. It's 400 odd meg, which is not enormous, but big enough. And as you can see, there's a whole pile of traffic going from our router 2 through router 1 and the switch to the server. And so let's just watch the progress, make sure we know when it finishes. And so, of course, as I said, this is backing up our operating system file onto the TFTP server. I must admit, this is the first job I do when we've got a new model of router, or even just a newer router of the same model that might have a newer version of iOS on it. And so, of course, you can actually transfer in the opposite direction as well. And so with that, you might have an updated operating system file. So, you know, a patched one, or maybe one with a different feature set, whatever it might be. And so you can actually, of course, do copy TFTP to flash, and that will copy the file from the TFTP server. Again, you'd need to know the file name, and then you can actually transfer it to the router. Now, of course, and you can do this on switches as well, of course. Now, of course, with that, you've got to be careful in that if you've got to check that there's enough space on the router to actually store it. Sometimes you might actually need to delete the iOS file from the router before you can then copy the new one on, which is a little bit risky because, if you lose power, you're probably going to have to go into ROM monitor mode and do a bit of a recovery before you can actually do anything. So that's always just a little bit interesting. But routers at least a lot easier to recover than switches. So the copy is still going, as you can see. There's all those exclamation marks. I'm not sure if that's one per packet or whatever, but it's quite a screen full. It will finish eventually. So server still there. Yeah. So it doesn't actually update this screen is actually not updated dynamically. I'll actually have to click away and then click back to actually see the file in the file system once it's finished. But we've got to wait until it's finished, of course. It does take some time. And it's still going. There we go. And so as you can see, okay, that's kilobytes, megabytes, yeah, so nearly 500 meg. So if we do the show flash, you'll notice that I think there's 2 gig available or something, so megabytes. So yeah, there's 2.7 roughly gig available space, and so copying a new one into this wouldn't be problematic. If we go back to here, click to DNS and then click back on the TFTP, you'll notice that now there is an ISR file, and so that's the file that we transferred. And so yeah, there we go. Now, of course, either backing up your operating system file or uploading a new file for the router, that's certainly one thing you can do. But another thing is you can actually back up your config as well. And so from here, you can actually do copy running config to TFTP as well. And so again, we need to know who the remote host is, 192.168.1.10. And because it's the config, you know, every config is different for every device. And so it's actually throwing the host name in -config as the file it will store. And so we'll do that. And of course, that was 736 bytes, not a very big file. So that transfer took very little time. So again, we can show the server. Out and in again. And it's first on list because it's a capital letter. And so, of course, it's in ASCII order. And so R2 config is now on the server. So that's another way that you can back up the config is by doing that. And so, yeah. So just other ways that you can actually manage your iOS files, basically. All right, so there isn't a lot else to do when it comes to this, but yeah, so that's pretty much all I was looking at demoing today. So basically you can do your show flash and then you do your copy flash to TFTP, which is of course what I did. And of course you can do your copy running config to TFTP as well. And so they're the things that you can actually back up and have, just so you can restore things a little quicker if you're running into whatever trouble there is. All right, so that's of course the end of the chapter 10 demo. And so we'll call that a day. I think chapter 12 is the next demo that we'll be doing, which is troubleshooting. And so we'll go on from there. So have a nice day. I'll see you again later. Yeah, have a good one.